About a dozen degrees to port, a small offset that decides whether she runs or is erased. On the evening of May 26, 1941, the steering gear of a 50,000-ton battleship locks into this fatal position. The jammed rudder forces the hull into a slow counterclockwise turn, presenting a fixed target to the pursuing British fleet. Gunfire can shred the superstructure, and a jammed rudder can doom the chase, yet neither by itself sinks a battleship. The jam turns escape into a geometry problem the engines cannot solve, and it leaves the ship trapped under pursuit. The physics of the loss begin here, with a mechanical seizure that fixes her course and invites the final punishment. A single torpedo impact has distorted the steering mechanism, creating a permanent constraint that no amount of engine power can override. The final moments of the surface battle are a blur of chaotic energy. But the salvage engineer looks only at the hydrodynamics. The ship lists heavily to port. The ocean pours over the rail, shifting the center of gravity past the point of no return. As the vessel capsizes and begins to roll, the laws of naval architecture trigger a catastrophic separation event. This is the moment where the wreck site is born, and it defines the first major feature of the debris field. The main battery consists of 4 massive gun turrets designated Anton, Bruno, Caesar, and Dora. Each housing carries 2 15-inch guns and weighs as much as a small destroyer. In the design of a battleship, these rotating fortresses are not simply bolted down like deck machinery. They ride on roller paths inside deep armored cylinders called barbettes, seated by gravity and guided by massive bearings so they can rotate under armor. On a steady, upright platform, that gravity-seated arrangement is an elegant solution, allowing the guns to rotate smoothly while bearing thousands of tons of armor. It works perfectly as long as the ship remains upright. When the hull inverts at the surface, that gravity-seated arrangement can fail. The weight that kept the turrets seated now pulls in the wrong direction. The turrets can tear free from their roller paths and drop out of their barbettes, beginning separate descents toward the bottom. In the modern debris field, these steel giants lie inverted and partly buried in sediment, stripped from the ship not by a direct hit to the turret crowns, but by the violence of capsize and sinking. Their loss leaves open barbettes and torn structure across the deck as the ship goes under. The ship itself, now lightened by the loss of thousands of tons of ordnance, begins its own descent. But the structural violence is not over. As the hull settles and the load paths shift, internal stresses build beyond what the weakened structure can carry. During the sinking sequence, the aft section, containing the chaotic ruin around the jammed steering gear, separates from the main citadel. The stern drops on its own, destined to land apart from the main body. What happens next may look like a rare hydrodynamic phenomenon. The main hull, inverted and broken, begins to sink. As trapped air escapes and the weight distribution shifts again, the center of gravity moves low. Somewhere in the descent, the wreck can appear to roll back toward an upright attitude, stabilizing rather than endlessly tumbling. The hull is now falling stable and keel down. It is dropping through absolute darkness, picking up speed toward a limiting plunge rate set by drag. The descent takes minutes, and the silence of the deep ocean is about to be broken by a violent impact. But the specific geology of the landing zone is waiting to complicate the forensic picture. The ship is not falling onto a flat plain, it is aiming directly for the slope of an extinct underwater volcano. The evidence of what actually killed the ship is about to be buried in a collision with the Earth itself. The impact is a glancing blow into the steep flank of an extinct underwater volcano. The 50,000-ton hull strikes the sediment with the energy of a freight train. The angle of the sea floor at this specific location is steep, a geological ramp that transforms the vertical fall into a horizontal disaster. The ship does not stop. It plows into the prehistoric mud and begins a violent, uncontrolled descent down the mountain face. This is the geometry trap of the Porcupine Abyssal Plain. If the vessel had landed on level ground, it would have buried itself in a deep impact crater. Instead, it carves a massive trench through the sediment, pushing a wall of mud ahead of the bow like a bulldozer. The slide continues for a little over 1 kilometer. This scar on the ocean floor is the primary anchor proof of the arrival mechanics. It is a geological wound that is clearly visible on sonar, marking the exact path of the battleship as it came to rest. The depth here is roughly 15 to 16,000 feet. At this level, the ocean is a pressurized tomb. The water column exerts a crushing force around 7,000 pounds per square inch. This is the deep, hostile environment where standard salvage rules do not apply. No human diver can survive here. No conventional submarine can operate at these limits. The darkness is absolute and the temperature hovers just above freezing. The only way to access this zone is through the use of specialized deep ocean vehicles. In 1989, deep ocean cameras finally illuminate the debris field, confirming the location after decades of uncertainty. But to truly understand the forensic condition of the wreck, later investigations draw on manned submersibles rated for extreme depth, including the Meyer vehicles. These are self-propelled, deep diving units built around pressure spheres designed for work in several miles of water. They are the delivery system for the human eye, allowing engineers to hover inches from the steel that has been lost for half a century. The slide scar itself tells a story of stabilization. As the ship tears down the slope, the friction of the mud acts as a brake. The hull eventually slows and settles, coming to a halt upright on the sediment. The violence of the slide has scoured the paint and stripped away lighter structures, but the main armored citadel remains intact. The ship sits proudly on the bottom, buried to the waterline in the mud it displaced. The surrounding area is a chaotic field of debris, including the turrets that tore free during the descent. The physics of the slide have preserved the hull in a way that a hard impact would not. The energy was dissipated over distance rather than instant deformation. This allows the survey team to examine the vertical surfaces of the armor belt, which are now accessible to the lights of the submersibles. The wreck is not a pile of scrap, it is a coherent structure, frozen in the moment it stopped moving. The orientation is stable, but the depth ensures that any operation here is a logistical challenge of the highest order. The environment preserves the steel, but it also hides the critical evidence. The mudline covers the lower hull, obscuring the torpedo hits that British reports claim destroyed the ship. The answers to the central mystery of the sinking are buried under feet of sediment, or hidden behind the massive armor plates that were designed to repel the very weapons the survey team is looking for. The ship has been found, but the cause of its death is still locked away in the cold zone. Sonar provides a shape, but it cannot provide every texture. To understand the forensic reality of the Bismarck, the survey team combines sonar mapping with optical sensors. In this depth, sound can outline the wreck against the terrain, while cameras confirm seams, surfaces, and specific damage. The team can then fly cameras directly over the structure, building a high-resolution mosaic in the visible spectrum. When the lights of the submersibles cut through the darkness, they reveal a phenomenon that defies the expectations of shallow water salvage. The most striking feature is not the steel, but the wood. The main deck of the battleship was originally plated with teak, a dense tropical hardwood chosen for its durability and resistance to weather. On a wreck in the North Sea or the Pacific, this organic material would often be among the first things to vanish, consumed by wood-boring organisms that thrive in oxygen-rich waters. But the environment of the Porcupine Abyssal Plain can slow that process. In the cold, dark deep, fewer of those shallow water wood eaters thrive, and decay can be dramatically reduced. The result is a ghost ship that looks ready for inspection. The teak planks are still in place, their caulking lines distinct, preserving the pattern of the deck just as it was laid down in the shipyard. The preservation is so complete that the paint markings applied in 1941 are still visible. On the bow and the stern, the cameras capture the distinct geometric forms of the swastikas, painted on the deck to identify the ship to friendly aircraft. These symbols have not been erased by the ocean. They have been locked in a low-energy stasis, providing an unmistakable confirmation of identity. As the cameras sweep aft, the damage to the superstructure becomes the dominant story. The funnel is missing, likely torn away by the hydrodynamic drag of the descent, or obliterated by shell fire during the final battle. The bridge structure is riddled with shrapnel holes, evidence of the intense surface engagement with the British battleships Rodney and King George V. The secondary armament, the smaller 5.9-inch, 15-centimeter guns, remains trained out toward the horizon, frozen in their final firing positions. This external survey creates a digital resurrection of the vessel, piecing together the violence of its final hours. However, the visual evidence presents a contradiction. The British reports state that the ship was sunk by torpedoes from the cruiser Dorsetshire. A torpedo warhead carries hundreds of pounds of high explosive designed to shatter the hull plating and flood the compartments. The survey team expects to see massive rents in the side of the ship, gaping holes where the ocean rushed in. Instead, the cameras reveal a hull that appears structurally continuous. The side armor, the massive belt of cemented steel that protects the vitals, shows the scars of shell impacts, but it does not show the catastrophic deformation of a successful torpedo attack. The external view suggests that the ship was battered into silence but not blown open. Forcing the investigation to tighten from panorama to proof. But to understand why it is on the bottom, the lenses must move off the deck and down the side of the hull to the interface between the armor and the abyss. Royal Navy accounts credit the cruiser Dorsetshires close-range torpedoes with the kill. If the wreck agrees, the side should show unmistakable underwater destruction. To test this claim, the investigation must move beyond the safety of the open water. The manned subs are too large to approach the jagged edges of the impact zones. The engineers deploy a smaller, more agile tool. This is a remotely operated vehicle, a compact robot fitted with cameras and lights, flown by a pilot inside the submersible. It is connected to the mothership by a thin fiber optic tether. This tether is the single point of failure. The robot must navigate through a minefield of torn steel, sharp wreckage, and hanging cables. If the tether snags or separates, the vehicle is lost forever in the darkness. The pilot must fly with surgical precision, threading the needle between the debris to reach the true skin of the ship. The target is the torpedo belt. This structure is the defining feature of the Bismarck class design. It is not a simple wall of armor. It is a calculated system of layered defense known as the armored citadel. The design philosophy relies on a sacrificial outer hull. When a torpedo strikes, the outer steel is expected to fail. The explosion vents into a calculated void space, a liquid-loaded compartment designed to absorb the shockwave and dissipate the energy of the gas bubble. Behind this void stands the holding bulkhead, a thick wall of high-tensile steel that protects the magazines and the engine rooms. The robot slips through the shredded sacrificial skin and into the blast zone below the waterline. Twisted seams and torn plating testify to violence in the first layer. Then the camera tracks inward toward the holding bulkhead, and the story stops being simple. In the areas the vehicle can safely reach and clearly see, the inner bulkhead is dented and scarred, yet it appears largely intact. That does not prove the citadel stayed dry, and it cannot by itself rule out fatal flooding elsewhere. It does suggest that at least some torpedo energy was absorbed as the designers intended, without an obvious straight breach into the heart of the armored citadel. The sinking may be cumulative damage and progressive flooding, plus the crew's last resort as capture became inevitable. The surface battle ends with a silence that is louder than the gunfire. The Bismarck is a burning ruin above the waterline. The superstructure has been reduced to shredded steel by the heavy shells of the Royal Navy. But the hull, the watertight envelope that keeps the 50,000-ton vessel afloat, remains stubbornly buoyant. The ship is not sinking fast enough to satisfy the British fleet, nor is it sinking fast enough to satisfy the German command. This is the moment where the tactical situation forces a permanent decision. The captain faces the certainty of capture if the ship remains on the surface. To prevent the vessel from falling into enemy hands, the order is given to initiate the final protocol. The mechanism of self-destruction is built into the design of every warship, though it is rarely used. These are the scuttling valves. In the deepest levels of the engine rooms, massive intakes draw ocean water to cool the steam condensers. These are not small pipes, they are industrial sluices capable of moving thousands of gallons of seawater per minute. By unbolting the flanges and opening the sea chests, the crew can turn the cooling system into a flooding system. It is a deliberate bypass of the pumps, allowing the Atlantic Ocean to flow directly into the bottom of the ship by gravity alone. Explosive charges are set in the cooling intakes to ensure the flow cannot be stopped. Forensic mapping locks that sequence in place, using the debris pattern to reconstruct the final timeline. The survey team plots the position of every fragment, from the massive gun turrets to the smallest piece of superstructure. When this map is complete, it reveals a clear narrative. The debris field is not the result of a catastrophic magazine explosion, which would have scattered the ship in thousands of directions. Instead, it shows a hull that remained coherent until the final inversion. The survey data indicates that the ship remained stable for a long period, settling lower and lower in the water as the compartments flooded evenly. This controlled descent is the signature of open valves, not the chaotic, rapid listing caused by asymmetric torpedo damage. As the internal volume fills with water, the stability vanishes. The ship capsizes to port and the gravity lock fails, releasing the 4 main turrets. The stern section, now heavy with flooded compartments, tears away from the main citadel as the hull inverts. This specific pattern of breakup is consistent with a ship that was fully flooded before it left the surface. The evidence lies in the fact that the citadel is largely dry of explosion damage but full of water. The investigation delivers a verdict that resolves 60 years of debate. The British torpedoes struck the armor belt and failed to penetrate the vitals. The shell fire destroyed the command and control, blinding the ship and silencing the guns. But the vessel itself was not killed by the enemy. It was executed by its own crew. The decision to open the intakes converts the ship from a combatant into a tomb. The water rises in the turbine rooms, extinguishing the fires and silencing the machinery. The evidence is conclusive. The Royal Navy stopped the ship, but they could not sink it. The German engineers finished the job. The survey closes the file on the loss, confirming that the fortress was breached from the inside by the very hands that built it. The Bismarck went down with its flag flying and its seacocks open, a final act of defiance that the deep ocean has preserved in the alignment of the steel. 2,200 men went into the water when the ship rolled over. Of that number, only 115 were pulled from the oil slick before the rescue effort was abandoned. The Bismarck is not merely a structural anomaly on the Porcupine Abyssal Plain. It is a war grave of significant magnitude. The debris field at 15,700 feet contains the remains of an entire generation of sailors, and the site is treated with the legal and ethical protections of a cemetery. The survey team observes the wreck, but they do not disturb it. The focus of the mission shifts from the forensic analysis of the steel to the observation of the biological timeline. The ocean is slowly reclaiming the 50,000-ton hull. In the deep cold of the Atlantic, the process of corrosion is different from the oxidation seen in shallow water. The battleship is being consumed by a specific form of deep sea life known as rusticles. These are not simple accumulations of rust. They are complex, living colonies of iron-eating bacteria and fungi. They cling to the vertical surfaces of the armor belt and the superstructure, hanging down like long, fragile icicles of oxidized metal. The rusticle is a highly efficient biological machine. The colony extracts iron from the steel plating, metabolizing it to sustain the community. As the bacteria feed, they excrete the waste product as a brittle, porous structure that grows inch by inch over the decades. This process is slow, but it is relentless. The formations act as a digestion system for the ocean, breaking down the strongest armor ever rolled by German mills and returning the elements to the water column. The hull is literally bleeding its mass into the sea, one dissolved molecule at a time. The survey reveals that the superstructure is suffering the most from this biological attack. The lighter steel of the bridge and the hangars is perforating, losing its structural integrity under the weight of the colonization. The heavy armor of the hull, however, remains defiant. The main belt and the barbettes are thick enough to withstand the consumption for centuries. But the appearance of the ship is changing. The sharp lines of the naval architecture are softening, replaced by the organic chaos of the bacterial growth. The swastikas on the deck and the teak planking are the only elements that seem immune to this specific form of decay, protected by their organic chemistry while the steel around them dissolves. The rate of deterioration suggests that the Bismarck has a finite lifespan as a recognizable vessel. The majestic profile that terrified the British Admiralty is being erased. Eventually, the structural supports will fail. The superstructure will collapse onto the deck. The hull plates will thin until they can no longer support their own weight, and the sides will fold outward, burying the interior in the sediment. The ship will transition from a technological artifact into a geological deposit, a concentration of iron oxide on the side of a seamount. The mission to the bottom has achieved its primary objective. The forensic evidence has settled the dispute between the torpedo and the seacock. The history books have been corrected. The battleship was not destroyed by enemy fire, but by the deliberate choice of its command. It fought until it could no longer maneuver, and then it removed itself from the board. The salvage of the truth is complete. Only the truth can be salvaged here. The steel must stay where it lies. The wreck will remain in the darkness, guarded by the pressure and the depth, slowly vanishing into the mud of the Atlantic floor. The investigation leaves the site as it found it, a silent monument to the 2,000 men who lie there, and a testament to the engineering that built a ship so strong that only its own crew could sink it.